All right, welcome back. This is the note session for attribute critter, and we're going to build on what we talked about in simple critter last time. Just as a quick review, last time we had talked about how we can define our own custom classes, and we looked at in these slides here this idea of a point class, and then we said that points could be defined in different ways, but that the constructor was what did the constructing of a point. And a default point could maybe be set up so it just initializes at the origin, right? 0, 0. And the attributes for our point, self.x and self.y, could be set to 0, 0. And that's how you could set up a straightforward default point. In our critter example, in simple critter, we looked at creating critters that were really basic, right? The only feature that a critter has at this point in time is an age. It's the only attribute that exists for a critter. It's an age that starts at 0. So when you construct a new critter, it gets set up at 0, right? And there's no way to change the age at this point. There's no way to customize our critters in any way, right? In our main program, when we created new critters, they were exactly the same, other than they were just different objects, of course. But they behaved the same way, right? When they talked, they said the same thing. When they slept, they did the same thing. We didn't differentiate these critters at all. So in this set of notes, we're going to learn how to differentiate objects using attributes. So for this set of notes, we're going to be in the attribute critter file. So make sure attribute critter is the file you are importing in your main. All right, so we'll learn about object attributes, and we'll also learn about a new method called the string method in the set of notes. All right, so we've got a construct. So we looked at basic points that weren't differentiated, but then we also looked briefly at this idea of attributes where we could differentiate our points. So an attribute, as a reminder, is just the data that's associated with an object. We'll call these instance variables at times, or attributes. And the constructor is the method that usually sets these up. It initializes the attributes for a given object. We use this self parameter in the constructor, as we talked about last time, which is an implicitly passed argument that references the object that's doing the calling. So with the constructor, when we construct this new object, the self just tells us which object, right? Which point is the point that needs to get set up with an XY. And then besides self, you can add a list of parameters, just like you would for a function, that allow you to pass in information to use in the method. So in this case, we could pass in values for points, so 50 and 100 for an XY coordinate. My other example, 3, 7 for these two different points. And then we'll set that information up in our constructor. We'll construct our point with a self.x attribute set to be the new x value, right, that was passed into the constructor. And then the self.y attribute set to be the new y parameter. Now, it's important to remember that the constructor is not explicitly called either. It's called when you call your class, right? So when I say capital P point, the constructor automatically will run and set this stuff up for us. So that way, when we create two objects, they can be different. So this example shows you a visual of our 2 points, P and Q, with different XY values. So jumping back into our Replit project, inside the attribute critter file, right, it notes again the definition of an attribute. And then it gives us a little shell of a class critter and then our main program. And we are going to redefine our class critter here to get practice typing some code and also to kind of add to some concepts we learned last time. So remember, all classes need a constructor. So double underscore init, double underscore self, and the end statements with colons. Keep using doc strings. So initializes a new critters attributes. We said that the age of all critters needs to start at 0. Right? And that self.age then is an attribute. So syntax, self.attribute is the syntax for attributes, for, I'll say, accessing attributes. We talked about this last time, but the constructor here automatically invoked. A new object is instantiated. Right, and to add to what we talked about last time, right, this can be a great spot to initialize attributes. So, and it can be used to initialize the attributes of an object. And now if we remember, we've defined this for a critter, but we haven't actually created any critters, and we can do that in the main. So we use our crit1 example again. And we call our critter class to create a new critter. And at this point, we don't have any information coded into our critter to pass in here, right? When we create this critter, new critter object, the only thing that gets passed is an implicitly passed reference to the new critter object, right? That gets assigned to self. And that's the only thing that exists here so far. And then when we create a new critter, we just want to be able to make sure that it worked. So I'm just going to print inside the constructor and just say a little message here. You know, let's say we'll say a new critter has been born. All right. So at this point, right, we're back to what we had last time, basically, where when we create a new critter, it says a new critter has been born. Right? But we want to be able to differentiate our critters now. So we said that we can pass information into the constructor. The way we do that is we pass it inside the parentheses when we call the class. right? So we have to list these after self. You want to make sure self is always the first parameter. And any other information you want. So maybe we give a name to our critter, and we have a mood for our critter maybe as well. So when we take this information in, we need to make sure we set our object up with it, right? So we need to make sure we create some attributes. So self.name, self.mood, that define this information for our critter. So the name is going to be set up to the initial new name parameter. And same thing for mood. In this case, to say a bit about what we're actually doing here, we're assigning the parameter value as the object's attribute to set it up, right? We're setting up our object's attributes. Right? And when we create this new critter now this time, it's going to have information, right? That might make it customized. So maybe we want to be able to see that. Maybe we say a new critter has been born, but maybe we say the critter's name as well. So new critter self.name has been born. And we say maybe like it is self.mood or whatever its mood is. Okay. And we could also include the age in that print, but when we create a new critter, they're all 0, right? So we'll leave that off of our print statement here. But now when we create a critter, right, if I try to run this now, it's going to tell me that there's a type error and that this init method is missing 2 required positional arguments, the new name and the new mood, right? Because I defined my critter as having a name and a mood. I need to make sure when I construct a critter that it has a name and a mood. All right, critter is going to be named Poochie. Poochie is happy. Right? So notice that only 2 arguments are sent here, right? And then obviously 3 parameters exist because self, again, right, is implicitly passed as the first argument. So we don't have to pass that in. We just start assigning, starting with the second parameter. Okay, so critter Poochie, and then we can create a second critter. So Randolph, we can give Randolph a mood as well. Maybe he is sad. Okay, so now with these 2 customized critters constructed, we can start to see that our critters are differentiated. So this first critter, Poochie, is happy. Randolph is sad. So it's getting more interesting now, right? Like they're actually differentiated. Okay, so that's fantastic. Now, when we start dealing with attributes, All right, oftentimes we want to figure out like, well, what is the current state of my object, right? Like maybe I've done some things, maybe the mood has changed, we've gone up in age, different things are happening to our objects over time. And we want to know like what's the state of our object at any given point in time. All right, this is where we get into our next special method, which is called the string method. So a string method is just going to be a representation of an object as a string returned. So typically it contains a description of all of an object's attributes, and it needs to include the method header defined using the double underscore str double underscore naming convention and the uh, naming scheme. And so, and it also does return. So that's important too. So it's going to actually return, not just print this string that is created. So you can see an example here for the point class where this point class is only showing you the string method at this point. The constructor and any other methods are omitted, but the string method creates a new variable, right, to hold this string. And then for a string is just an XY coordinate. So you just create a string that shows the X and the Y coordinates and returns it. And when you do that, the usefulness of doing that is now when we have a given point, right? So this example point object here, P, we can print P and it will now print the returned string from the string method. So we'll be able to see what is this point like just by printing the point, which is really, really useful. So, so we can see this, and we can see that it doesn't work. Let's show you how it doesn't work first. So we can use, well, let's just do this first. So we'll go ahead and print out a note that we are going to be printing this crit1 variable. Then we're going to do the same thing for crit2. Okay, so then we're just going to print the object. Okay, when we do that, without a string method implemented, crit1 printed shows you this angle bracket, noting that there's this object at this like that funky hexadecimal, string, which really is just referring to a object location in memory where you can find this critter object that you constructed. Right? So you can see the object locations are different for our two critters. So we know they are different objects, right, which I guess is useful. But beyond that, this isn't very useful, right? We can't really tell what defines these critters. And that's why we need a string method so that we can actually print out something useful when this runs. So let's go ahead and do that here. So we'll define a string method. You don't have to type all of this in, but I'm going to go ahead and put a big description of what we're going to do here in. So this string method will create a string representation of our object and return it. Typically, this contains the description of all the attributes, like we said, and it has to follow the naming convention of the double underscore str. Right? And this will allow us to print something better than what we just saw. So here's our naming scheme, str underscore double underscore. You need to include the self because we still have this fact that there are many different objects that might exist. We need to know which one we're printing the information for. Docstring just explains what a string method is for a critter. And then we can create a variable, maybe call it myString. And maybe it starts out empty. And then we can just concatenate on all the information we need for a critter. Right, so let's add on to this empty string. So we'll add a string that prints out the name. So, oh, and now another common mistake that I almost just made is commas. Right, so commas, remember, separate arguments. So we can't use a comma with concatenation, right? So everything has to be added and concatenated onto our big string. If you have a lot of information, like we're starting to get a lot of information for a critter, there's 3 different attributes. It's nice to kind of like format it nicely. So like doing some \n gives you a new line. Describing what I'm doing, the attributes you're actually displaying is useful. So we can see the name of the critter. We can see the age of the critter. And name, mood, and age are the only ones we have. So we'll say, let's do it again, self.age. Right, but notice, because we're just creating one big string, we cannot concatenate things that are numbers, right? Self.age is an integer value. So if you run across that, you're going to have to use your string conversion method to convert it to a string. Right, once you've got your string constructed, you just return it. Common mistake also to print right here. Right now that you've got the string, well, I want to print it. But that's not exactly the behavior we want. We want to return it so the printing can be done when we print the object. So this looks good now. So now when we print crit1 and crit2, that string method will be called and it will return and print the information for our critters. Let me see. Okay. So you'll notice that when I'm doing this, I must have made a mistake because currently it's still printing the, not the string that I just constructed in the string method. It's printing like still the object location. And I'm glad I did this because this is just showing that this is really easy to do. It's just to be off in your indentation as you write these classes. I'm not indented enough over here, right? Like this whole thing has to go in a level, right? Because this belongs to my class critter. So if I indent it, then I can see critter1, Poochie, happy, age 0, and critter2, Randolph, sad, age 0. So we have these unique critters at this point. So down here below, just make a note that we can use the string method by printing the object's reference variable. Right. When I say reference variable, I'm talking about just the variable that contains our objects. So crit1 and crit2. All right, this looks pretty good so far. As a challenge, make sure you know how to use these instance variables that we just dealt with. Go ahead and write a new method that prints the object's name, age, um, right, let's make this called a talk again. So kind of like we did in the last set of notes, we'll write a talk method that allows our object to print the object's name, age, and mood. Also, you could make talk display a custom message for a critter. Let's go ahead and pause the screencast and give that a try. All right, welcome back. So when you talk with a critter, you're going to define a method called talk. Make sure you have a reference to the object with the self. And then the same way we did in the string method and even the constructor, we did some of this. The way you reference the attributes for name, age, and mood would be right here, right? Now this talk method looks fine, but it really is just displaying what the critter is, right? Which is the whole reason why we have a string method, to display the information for the critter. So when you're talking now, maybe you don't want to do this anymore. Maybe you want to print out some message, some custom message for a critter to say. And then you could say something like, you know, this critter says, some message. Right? So that when you go and talk with your critter now, you can make critter one talk. Critter one is Poochie. Say something. When you run it, indentation error on line 33. We'll fix that. And then you get Poochie says, it's a great day to be a critter. So then you've got a customized talk method for your critter. Okay, and that is it for the attribute critter notes.